So problem 2, we just need to find the inverse of the exponential function. So the inverse is just when we switch our x's and our y. So originally we started off with y equals 2 to the x minus 3 minus 4. Switching my x and my y, I would get x is equal to 2 to the y minus 3 minus 4. Alright. And then now I just need to resolve for y. So resolving for y, I'd have to have that x plus 4 now is equal to that 2 to the y minus 3. Alright, and then from here, I want to get my x's out of my exponent, or in this case, my y exponent. So now this is where logs come into play. So the really cool thing about logs is it is going to say, okay, I've definitely got the log of x plus 4 is going to be equal to, well, since that's just a number, the number is still going to stay in the log of 2. Okay. But the really neat thing is that exponents will actually come out in front of that log. So I've got that y minus 3 now in front of my log. Alright. So from here, still trying to solve for y, so I need to divide both sides by a log of 2. So then I'd get log of x plus 4 divided by log base 2 is equal to y minus 3. Alright, and then this is what we call the change of base formula. So I can take log base now 2, because your base is always going to be on bottom, of that x plus 4, the stuff on top, is going to be equal to that y minus 3. Other than that, I just need to add that 3 over, so I'm going to have log base 2 of x plus 4 plus 3 is equal to y. Alright, so the inverse then is just that log base 2 of x plus 4 plus 3 is equal to y. And then whenever you guys start talking about inverses, you learn that, hey, my domain is the set of all my x's, my range is the set of all my y's, and inverses, well, they just switch my x's and my y's, so it makes sense that if I know my domain of my regular function, which I do from problem 1, and my range from my original function, which I do from problem 1, then all I have to do is switch my domain and my range. So my range of my inverse is now going to be all reals, and then my domain of my log function is going to be that set of all x's such that x is greater than negative 4. Oops. Alright. Nifty. Okay, so that's pretty neat. But back here, I accidentally said x's, and I 100% meant to say y's, because it's dealing with range. So, if I don't get the chance to fix that in the first video, please know that I meant y's. Alright, so all I have to do now is basically just flip my x's and my y's from problem 1. So literally go grab your points off problem 1 graph and flip your x's and your y's, and that should be it. So my asymptote is now at x equals negative 4. Alright, and then from there, so you should have a point at negative 3, positive 3, negative 2, positive 4, 0, 5, 4, 6, and then 12, 7. So again, all I did was I took my points from this graph and I swapped them out. I switched my x's and my y's around. That's legitimately all that I did. Alright, from there, I just connect the dots. The other way you could have done it is by just actually plugging in numbers for x and seeing what you get out for y, but you gross. If you don't have to, I wouldn't. Alright, and I kind of already said that this is the shorter way. That's honestly the only way that I really remember other than plugging stuff in. But the easiest way is to probably just graph your original exponential function and then swap your x's and your y's. And that's about it. Alright, other than that, see you guys in my next video. I will try not to mess that one up.